Have you ever wondered if we're alone in the universe? The quest for habitable exoplanets, those celestial bodies outside our own solar system capable of sustaining life, is a fascinating journey driven by this very question. These exoplanets, if found, could potentially harbor life forms, and their discovery would be a monumental leap in our understanding of the universe. This journey is not just about finding another Earth, but about the intriguing possibilities that lie beyond our solar system. It's a quest fueled by our innate curiosity and our yearning to reach beyond the stars. We're not just looking for planets. We're seeking answers to some of the most profound questions that have intrigued humanity since we first looked up at the night sky. As we delve deeper into the cosmos, the possibility of discovering life beyond Earth becomes increasingly real. So buckle up, because we're about to embark on an extraordinary journey, a quest for habitable exoplanets. What makes an exoplanet habitable? It's all about being in the right place at the right time. And by right place, we mean the Goldilocks zone, a term that comes from a fairy tale about a little girl who liked her porridge not too hot, not too cold, but just right. The Goldilocks zone, or habitable zone, is the region around a star where conditions might be just right for life as we know it. Why is this so important? Well, it's all about water. Life on Earth is water-based, and we believe that any potential life outside our solar system would also require this vital ingredient. In the Goldilocks zone, the temperature is just right for liquid water to exist on the surface of a planet. Too close to the star, and water would simply boil away. Too far, and it would freeze solid. But being in the Goldilocks zone is just the start. An exoplanet also needs the right atmosphere. Atmosphere acts like a blanket, trapping heat and creating a stable climate. It also protects life from harmful solar radiation. And let's not forget about the composition of that atmosphere. For life as we know it to exist, certain gases like oxygen and carbon dioxide are essential. The stability of the planet's climate is another crucial factor. Wild fluctuations in temperature and weather conditions could make it difficult for life to take root and thrive. A stable climate, on the other hand, gives life a fighting chance to evolve and adapt. And finally, we have to consider the exoplanet's proximity to its host star. A planet that's too close might be subjected to powerful solar flares, while one too far away might not receive enough heat and light for life to flourish. So, what we're looking for in our search for habitable exoplanets is a delicate balance of many factors. It's a bit like trying to find the perfect house. Location matters, but so does the structure and condition of the property itself. Finding an exoplanet in the Goldilocks zone is like finding a needle in a cosmic haystack. But with every new discovery, we're getting better at knowing where to look and what to look for. And who knows, maybe one day we'll find that perfect cosmic home that's just right. The search for exoplanets has been revolutionized by two groundbreaking missions, Kepler and TESS. Let's delve into these missions and their extraordinary contributions to exoplanet discovery. The Kepler mission, named after the renowned German astronomer Johannes Kepler, was a marvel of modern astronomy. Launched in the year 2009, Kepler's primary objective was to identify exoplanets in the habitable zone of their stars. Equipped with a photometer to continuously monitor the brightness of over 150,000 stars, Kepler was on the lookout for periodic dips in brightness, indicative of an exoplanet passing in front of its star. This method, known as the transit method, was a pioneering approach in the hunt for exoplanets. The results were nothing short of astonishing. Kepler identified over 2,000 confirmed exoplanets, with many more potential candidates still under review. These discoveries spanned a wide range of sizes and orbits, including many located within the habitable zone of their stars. Kepler's discoveries have undeniably reshaped our understanding of our place in the cosmos. Following in Kepler's footsteps is the Transiting Exoplanet Survey Satellite, or TESS. Launched in 2018, TESS has taken up the mantle from Kepler, embarking on a comprehensive survey of the entire sky. Its mission: to identify exoplanets around the brightest stars in the night sky, providing a rich dataset for further study by future missions. TESS has already proven its worth, identifying hundreds of confirmed exoplanets and thousands of potential candidates. Its discoveries, along with those of Kepler, have shown us that exoplanets are not the exception in the cosmos, but the rule. These missions have opened a new window into the cosmos, bringing us closer to finding a second Earth. The legacies of Kepler and Tess are not just in the exoplanets they've discovered, but in the way they've revolutionized our approach to studying the universe, paving the way for future explorations. Among the thousands of exoplanets discovered, some have shown promising signs of habitability. Two of the most intriguing candidates include Proxima Centauri b and TRAPPIST-1e. Proxima Centauri b orbits the closest star to our solar system, Proxima Centauri, which is a mere 4.2 light-years away. This exoplanet's position within the habitable zone, also known as the Goldilocks zone, where conditions are just right for liquid water, makes it a prime candidate for potential life. Its parent star, though smaller and cooler than our Sun, provides a warmth that could potentially sustain a stable climate and liquid water on the planet's surface. Meanwhile, in the constellation of Aquarius, some 40 light-years away from Earth, lies the TRAPPIST-1 system, a fascinating collection of 7 Earth-sized planets. Particularly intriguing is TRAPPIST-1e, which resides comfortably within the system's habitable zone. This exoplanet is roughly the same size as Earth, and researchers believe it has a higher likelihood of possessing liquid water, a crucial ingredient for life as we know it. These exoplanets, Proxima Centauri b and TRAPPIST-1e, are considered potentially habitable due to their position in the Goldilocks zone and their similarity in size to Earth. Yet, it's important to remember that the term habitable does not necessarily mean inhabited. It simply implies that these planets could potentially host conditions suitable for life, not that they do. Significant research is still required to further understand the atmospheres and surface conditions of these exoplanets. Are they rocky like Earth or gaseous like Jupiter? Do they have protective magnetic fields? And most importantly, do they have the necessary ingredients for life? Carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, in an environment where complex organic chemistry can occur. Answering these questions will help us narrow down the search for life beyond our solar system. As we continue to explore these distant worlds, we are learning more about our place in the cosmos. These exoplanets, so different yet so similar to our own, continue to fuel our curiosity and optimism. When it comes to habitability, it's not just about the planet itself, but also its atmosphere and moons. The atmosphere of an exoplanet is a significant player in determining its suitability for life. Why, you may ask? Well, let's think about Earth. Our atmosphere retains heat, protects us from harmful solar radiation, and contains oxygen, which is vital for most life forms. The study of exoplanet atmospheres can provide us with a similar understanding about these distant worlds. By analyzing the light that filters through an exoplanet's atmosphere during a planetary transit, scientists can identify its chemical composition. This technique, known as spectroscopy, is crucial in our search for habitable exoplanets. One of the most exciting outcomes of this analysis is the detection of biosignatures, such as oxygen and methane. These are gases that, when found together in an atmosphere, are a strong indication of biological activity. In other words, the presence of these gases could suggest that life exists or once existed on that exoplanet. But what about moons? They too can play a pivotal role in the search for extraterrestrial life. Exomoons, or moons orbiting exoplanets, could potentially harbor conditions suitable for life. In our own solar system, moons like Europa and Enceladus have shown us that habitability is not limited to planets alone. These moons, with their subsurface oceans, could serve as a habitat for life. Studying exomoons, however, is a challenging feat. Their relatively small size and close proximity to their parent planets make them difficult to observe. Yet the potential payoff of discovering a habitable exomoon is too great to ignore. So as we continue our cosmic quest for habitable worlds, we must consider not only the planets themselves, but also their atmospheres and moons. Each of these elements provides a piece of the puzzle, a clue in our search for life beyond Earth. From atmospheres to exomoons, every discovery brings us one step closer to answering the question, are we alone? As we look to the future, advancements in technology and astrobiology promise to propel our understanding of habitable exoplanets even further. Astrobiology, the study of life's potential in the universe, is broadening our perspective on what kind of environments could sustain life. The discovery of extremophiles, organisms that thrive in Earth's harshest conditions, opens up a world of possibilities for life on other planets. Emerging technologies are set to revolutionize our exploration of exoplanets. The James Webb Space Telescope, for instance, is a game changer. It's designed to peer deeper into space than ever before, analyzing exoplanet atmospheres with unprecedented detail. This will allow us to detect biosignatures, the potential signs of life, with greater accuracy. The future of exoplanet exploration is a journey of discovery, a journey that may well lead us to find life beyond Earth. With each new discovery, we inch closer to potentially finding life beyond our own planet, forever changing our understanding of our place in the cosmos.